Hey space enthusiasts, welcome back to your channel name, where we unravel the mysteries of the cosmos and bring you closer to the wonders of the universe. Today, we're diving deep into a captivating new discovery that's got scientists buzzing. A discovery that suggests our moon, in its infancy, might have had some tiny companions orbiting alongside it. Yes, you heard that right. Long before our moon settled into the stable orbit we see today, it may have had a few mini-moons by its side. Curious? Let's journey back billions of years to uncover the secrets of our early Earth-Moon system. Imagine the Earth 4.5 billion years ago. The planet is a newborn, still glowing from the intense heat of its formation. Suddenly, a colossal event occurs. A Mars-sized body, often referred to as Theia, slams into Earth with unimaginable force. The impact is so powerful that it ejects a massive amount of debris into space. Over time, this debris begins to coalesce, forming what we now know as the moon. But here's the twist. What if, in those chaotic early days, the moon wasn't alone? What if it had siblings, small moonlets, that orbited alongside it, caught in the gravitational embrace of the Earth-Moon system? Today, the moon orbits Earth at a distance of about 239,000 miles, 384,600 kilometers. But in those early days, it was much closer. Just 1,190 miles, 1,935 kilometers away. That's about 1.5 times the diameter of Earth. This close proximity would have made the Earth and Moon appear dramatically larger in each other's skies than they do today. But there's another mystery to unravel. The Moon's current orbit around Earth is tilted by about 5 degrees relative to Earth's orbit around the Sun. This tilt has puzzled scientists for years. Why isn't the Moon's orbit perfectly aligned with Earth's? What caused this tilt, and how did the Moon end up in its current orbital path? A recent study offers a fascinating clue. Scientists now believe that the gravitational pull of debris left over from the Moon's formation could have played a significant role in shaping its orbit. In those early days, the space around Earth and the Moon was far more crowded than it is today. Smaller bodies, chunks of rock, and dust from the initial impact likely orbited the Earth-Moon system. These orbiting materials could have tugged at the Moon, influencing its orbit and contributing to the tilt we observe today. But here's where it gets even more interesting. The researchers propose that some of this debris might have settled into circumbinary orbits, those that revolve around both Earth and the Moon, not just one or the other. These orbits could have been stable in the distant past, even though they wouldn't be today. This means that Earth and the Moon might have once had a companion, a small moon or a disk of material that orbited around their poles, rather than around their equators. Think about that for a moment. A tiny companion orbiting the Earth-Moon system, influencing their orbits, and playing a key role in the evolution of their relationship. This companion, if it existed, could have been a crucial factor in shaping the Moon's current orbit, contributing to the tilt that has puzzled scientists for so long. While this material would have disappeared over time, possibly colliding with Earth or the Moon, or being ejected from the system entirely, its presence in those early days could explain many of the mysteries surrounding the Moon's origin and orbital evolution. But this discovery doesn't just change how we think about our own moon. It opens up a whole new realm of possibilities when it comes to exoplanets, planets orbiting stars beyond our solar system. If polar orbiting material existed in our own solar system, could it be out there in exoplanetary systems too? Imagine distant planets with moons that have their own tiny companions, locked in a complex gravitational dance that we've never witnessed before. These polar orbiting moonlets could change the dynamics of exoplanetary systems, potentially leading to observable effects that could one day be detected by our telescopes. This discovery also raises new questions about the stability of such orbits. While our Earth-Moon system no longer supports these polar orbits, it's possible that other systems could. If these orbits can exist elsewhere, what impact might they have on the formation and evolution of other moons and planets? Could they even influence the potential habitability of these distant worlds? The study that revealed these insights has been accepted for publication in the Astrophysical Journal, a prestigious platform where groundbreaking research in astronomy and astrophysics is shared with the world. As we continue to explore the universe, findings like these remind us just how much there is still to learn about the cosmos and our place within it. So, what do you think? Could our moon have had some long-lost siblings that played a key role in its development? And could similar mini-moons be orbiting distant exoplanets right now, shaping their destinies in ways we've yet to discover? The universe is full of mysteries, and this discovery is just the beginning. Let's get the conversation going in the comments below. What questions do you have about our early Earth-Moon system? Do you think we'll ever find evidence of these lost mini-moons? And what might they tell us about the evolution of other planetary systems? Don't forget to like, subscribe, and hit that notification bell so you never miss out on the latest cosmic discoveries. Until next time, keep looking up and keep wondering.